Hello! In the last video we add the possibility to player to control the character. Today we are gonna add some NPC to interact with. Let's add 2 NPC that will guard the bridge and 1 NPC somewhere in the wild. For now we will use rectangle placeholders for them just for prototyping, and later we will add some actual sprites. Okay, let's introduce variables for NPC. And draw the rectangle and NPC name above it. Nice! Now we have placeholders drawn onto the screen. But do you see a problem here? Every time we want to add or remove an NPC, we have to define a set of variables as well as call draw function. Also, we introduced a lot of code repetition, which can be a problem as a project grows. Let's think more about gameplay. Now we have a hard-coded number of NPCs on screen. But what if we want to add or remove an NPC dynamically? For example, if NPC dies, we don't need to render it. Or to make a sort of random encounter, we will need to spawn several enemies at the time. So, our initial approach is workable but far from good. It's a perfect time to introduce another basic data type in Python, list. Lists are used to store multiple items in the single variable. Lists are mutable, which means that lists can be modified by adding or removing elements. Sounds like exactly what we need, so let's refactor our NPC variables. To define a list, you should use square brackets and values separated by the comma. It's already starting to look much better. But how do we render NPC using lists? Let's do it straightforward first. You can access every item in the list using its numeric index starting from 0. Alice name will be NPC name 0 and coordinates NPC x0, NPC y0. Bob will have index 1 and John index 2 correspondingly. Let's code it. Good. But does it really solve our issues? Not really. We still manually code every NPC draw logic, so what's the point? We can call drawing logic for every NPC in the loop. Loops used when you need to repeat some logic until loop conditions are met. Python has 2 loop primitives, while loop and for loop. We will start with the while loop. Let's look at our code. We call a specific set of functions to draw an NPCs, and they are all the same except the NPC index in our list. So, we need to iterate on the NPC index starting from 0 to 2. And you need to add one to the NPC index. Or you can use the shorter form. And we don't need this anymore. If you look closely, it really looks like the condition we talked about earlier. But in this case, the condition is checked before every iteration. If the condition is true, then the loop code is executed, and if false, program exits loop. Let's talk through it. First, we define a variable that represents the current NPC index and call loop control variable. It is 0 because list indexes start with 0. Then we start the loop with the condition that NPC index must be less or equal to, since we have 3 NPCs. On each iteration, we execute NPC draw logic and add 1 to the NPC index, so that on the next iteration, the next NPC will be rendered. Cool. But what if we add or remove NPC from the list? Let's try and remove John from the list. As you may expect, our code fails, because it's tried to render NPC with index 2, but there are no such NPC in the list. How do we fix it? Instead of hardcoding NPC count in the loop, we can get list items count with function len. Now it works. We can return John to the list and check that it's still working. You may ask, why do I change the condition to strict less than? Let's think. Len with NPC names as argument will return 3, which is right. But as I said, lists are numbered from 0. So if we will iterate till 3, we will end with 4 total iterations. 0, 1, 2, 3. Let's test it. As you can see, it fails. This is a classic error called off by 1. Okay, we solved all issues from the first naive implementation. But can we do better? Sure we can. List could contain not only simple values, but other lists too. Let's declare our NPC as a list of name, x coordinate, y coordinate. For example, so our NPC's list will look like this. Every NPC list now has all the data associated with it. 0 index is the name, 1 is the x coordinate, and 2 is the y coordinate. The NPCs list is now holding all NPCs. This structure is called two-dimensional list. Let's update our drawing loop. As long as it's perfectly working code, it becomes slightly hard to read, isn't it? We can refactor it using a for loop. The difference is that for loop is specifically designed to iterate through sequences like lists. The syntax is simple. As you can see, it's much clearer and sounder now. We get rid of manual index manipulation, len calculation, and incrementing loop control variable. The only problem with this implementation is that we have to remember every parameter we have in the list and its index. For example, if we mix values order in NPC list, our code will be broken. But we will face this issue in the next video. We just scratched the surface of Python containers and loops. The possibilities are nearly endless. And we'll get back to the list later in this course. If you enjoy this video, give it a like and subscribe to the channel. Ciao!